Okay, so we are on question number 11. Question 11 says, or is on the topic of earth geometry, and we're given a drawing of the earth, and we've got point A there, we've got our point B there, we've got our point C there, and we're told this is 30 degrees west, 75 degrees east, and 60 degrees north, 0 degrees, and 30 degrees south. So the first question is asking us to say, if the local time at point B is 15 hours, find the time at C. So we need to identify where our B is. So our point B is here. So point B is lying on longitude, this is 30 degrees west, and this is 30 degrees south. And point C is lying at point 75 degrees east. And what else are we given? This is also 30 degrees south. And we're asked to say, if the local time at point B is 15 hours, find the local time at point C. So when we are dealing with, when we're doing coordinate geometry, or rather earth geometry, and we're dealing with time, we need to know to say that as we move from west to east, time increases. If we're moving from east to west, time is reducing, is decreasing. And we also need to know to say, when we've got 2 points or 2 locations that are lying on different in different hemispheres, let's say the north and the south, to find the difference in longitude between the 2 points that we have, we need to add. If they're both lying in the same hemisphere, let's say it's the east and the west, rather the east and the other one is also in the east, we need to subtract to get the difference in longitudes. So if they're in different hemispheres, north, rather east and west, we add. Same hemispheres, we subtract. Okay, so let's look at point B and point C. Point B, we're told to say, is on 30 degrees west, or point C is on 75 degrees east. So what really determines the time difference are the longitudes and not the latitudes. The longitudes, which are 30 degrees west and 75 degrees east. So these are lying in 2 different hemispheres. So to find the difference in longitudes between the 2 points, we need to add the 30 degrees and the 75 degrees, and that will give us the difference in longitude. So the difference in longitude between these 2 points is 30 plus 75. So 30 plus 75 will give us 95. So 95 degrees is the difference in longitudes between point B and point C. So since we're moving from point, we've been given the time at point B and looking for the time at point C, we're moving from west to east. What we need to do is we need, or rather what we're going to get is, we're going to find that the time is increasing, and the time difference between this one and that one will be an increase as we go from B to C. So now, how do we know how many hours have increased or are the difference between these 2 points? So we need to remember to say, for every 15 degrees moved, we have 1 hour either added or subtracted. So in this case, since we're moving in this direction, 1 hour is added. So we need to find how many 15 degrees are in this 95. So we're going to say, so I can erase the question that we have. So to find the number of 15 degrees that are in 95, we're simply going to divide the 95 by 15. So what is 95 divided by 15? With 15, 30, 45, 60, 75, and 90. So we've got 6 15 degrees in 95. So we've got 6 with a remainder of 5 degrees. So you can say 5 or 15. Okay, so we've got 6 hours, or rather 6 15 degrees, and the remainder of 5 degrees as after we divide. Okay, so for every 15 degrees, we know it's 1 hour. So in short, we've got 6 hours, 6 hours. So now we'll deal with the remainder. So we've got 6 hours, that's the time difference. So the remainder is going to give us the number of minutes that are that have been added to these 15 hours that we have. Okay, so to find the number of hours, we're going to say 15 degrees gives us 1 hour, which is 60 minutes. 60 minutes. So how many minutes are in 5 degrees? We'll say x. So to find the value of x, we'll cross multiply. We're going to have 15x equals 5 multiplied by 60. 60. So what is 5 multiplied by 60? 5 by 6 will give us 30. So we've got 300. So we've got 15x equals 300. And we can divide both sides by 15. 15 and 15. So we've got this 15 and that 15 goes. And 15 into 30 is simply 2. 15 into 0 will give us 0. So we've got 20. So we've got 6 hours and 20 minutes. That is the time difference between the 2 points. But we're not asked to find the time difference. We are asked in the question to find the actual time that is at C. So to find that, we're simply going to add, as we said, since we're moving from west to east, we are adding. So we're going to add 6 hours 20 minutes to the time that we have at B. And the time that we have at B is 15 hours. Actually 15 hours exactly. So we're going to say 15 hours plus 6 hours 20 minutes. So we start with the minutes. 0 plus 0 will give us 0. 2. 15 plus 6 will give us 21. So the time at point C is 21:20 hours. Question 11b says it takes a plane 6 hours to fly from point A to point B. What is the speed? What is its speed in knots? So it takes a plane 6 hours to fly from point A to point B. What is its speed in knots? So you know that the formula for speed is equal to distance over time. So we're given the time, but we do not have the distance. But they know that we can calculate the distance. So how do we find the distance? To find the distance, we use the formula, or rather the equation, theta over 360 multiplied by 2 pi r. Well, this is capital R. Capital R is denoting the radius of the Earth, because longitudes have the same radius throughout. This longitude has the same radius as that longitude, and that is simply the radius of the Earth. So the capital R is representing the radius of the Earth, and theta in this case is representing the difference in latitude between the 2 points. So we've got, this is lying on 60 degrees north, this is lying on 30 degrees south. So the difference between these 2 points is theta, is what we replace in the theta. So let's go on. And we're told to say we find the speed in knots, meaning for the radius of the Earth we use nautical miles. And nautical miles, the radius of the Earth given in nautical miles is simply 3970. Let's go with that. So we're going to replace what we have into this equation to find the distance between these 2 points. Okay, so what is the difference in latitude between point A and point B? So we're going to say this is on 60 degrees north, 30 degrees south. So these two are lying in different hemispheres, north and south. So to find the difference in latitudes, we're going to have to add the 2 latitudes on which these 2 points are lying. So we're going to say 60 plus 30, which will give us 90. So we're going to have 90 over 360 multiplied by 2. Are we given the value of pi in the question? So the question doesn't give us the value of pi, does it? Okay, so we assume it's 22 over 7 multiplied by the radius of the Earth, which we've said is 3970. Okay. Okay, and we can solve this we can perform calculations on this. So 0 there, 0 there, 9 there, 1, 9 into 36 is 4, 2 there, 1, 2 into 4, 2, and 2 there is 1, 2 into 22 is 11. Okay, so we can multiply the 3970 by 11. Actually, you can just forget about the 0, put it there. It's going to be 7, 9, 3, 0, 7, 9, 3. This will give us 7, 16, 13, and 4. So we've got 4, 3, 9, 7. Okay, so we've got 4, 3, 6, 7, 0 over 7. Am I right? Yes. Then we can divide 3 out by 7. 7 there is 1. 7 into 43 will give us 7 into 43 will give us 6. Remainder 1. 7 into 16 will give us 2. Remainder 2. 7 into 27 will give us 7 into 27. 7 into 27 will give us 3. Remainder 6. And 7 into 60 will give us 8. 8. Remainder 4. So we can say 0.4. Okay, so we have, let me write it here. So we have 6238.4. Okay, let's leave it there. This is our distance in nautical miles. Now to find the speed at which the plane was moving, we say speed equals distance over time. Now distance is that, so we're going to have 6238.4 divided by the time that we've been given is hours. So 6 into all of this, we're going to have 6 into 6 is 1. 6 into 23 will give us 3. Remainder 5. 6 into 58. 6 into 58 will give us 9. Remainder 4. Remainder 4. Okay, so maybe we can just round this off to 139.5 knots. And this is a rounded off answer, so you can counter check to look for where we might have gone, where we might have made errors in our calculations. But generally, this is a general idea that we use to tackle such questions. Okay, question 12. A, we're dealing with indices. We've got 3 to the power 0 multiplied by 3 to the power 3 plus 3 to the power 1. So we get into it. So you need to remember to say any number multiplied to 0, any number raised to the power 0 is 1. So this is basically 1 multiplied by 3 to the power 3. It's simply 3 multiplied by 3 multiplied by 3. This is 3 multiplied by 3 will give us 9. Multiplied by 3 will give us 27. So this is simply 27 plus 3 to the power 1. Any number raised to the power 1 is the same number. So this is simply 3 to the power 3. This is simply 3. So 1 multiplied by 27 is 27 plus 3. 3 plus 27 is 30. So this is quite simple and straightforward. Move on to B. So in question 12b, we're given a sector and we're asked to find the angle theta given the radius 4.2 and the area being equal to 9.24 centimeters squared. This is in centimeters as well. So how do you find the area? So to find the area of a sector, the formula that we use is area equals half r squared theta pi over 180. This is the formula that we use. So maybe let's simplify this. 2 multiplied by 180 will give us 360. So area is simply equal to r squared theta multiplied by pi over 360. Okay, this is the formula that we are going to use. Okay, so this is the formula that we use. We're trying to make theta is subject to a formula. We cross multiply. We have 360 multiplied by the area. Let me write this straight. 360 multiplied by the area is equal to what we're going to remain with on this other side. Pi over 360. What we're going to remain with on this other side is r squared theta pi. And if we want to make theta is subject to a formula, we divide both sides by r squared theta. We're going to have theta equals 360 area divided by r squared pi. R squared pi. Okay, so we've gotten this far. This is the formula that we're going to use to find the angle theta. So we can start replacing. So we're going to have theta equals, what is our area? Our area is 9.24 multiplied by 360 divided by, what is our r? Our radius is 4.2 squared multiplied by 22 over 7. Okay, so this is paper 1. You're not allowed to use the calculator. We have to do this. We have to do all this work using our minds, using our heads. So 9.24 multiplied by 360, we got 4.2 squared multiplied by 22 over 7. Okay, let's start with evaluating 4.2 squared. 4.2 multiplied by 4.2. You can say 42 multiplied by 42. 2 multiplied by 2 will give us 4. And this will give us 16. 0. 16. Sorry. 2 multiplied by 2, 4. 8. 0. 6, 8. Then 1. 8. Then 16. This will give us 4, 16, 7, 1. We had 2 decimal places, so we'll do that. So this is, and then we can, so this is 17.64. We can also calculate 9.24 multiplied by 360. 9.24 multiplied by 360. You can simply say 924 multiplied by 36. 924 multiplied by 36. 6 by 4, 24, 6 by 2, 12, 14, 6 by 9, 54, 55, 0, 3 by 6, 12, 3 by 2, 6, 7, 3 by 9, 27. Okay, and then we can continue. So we add the numbers that we have. We have 4, 6, 12, 13, 3, and 1. So we've got 1, 3, 3, 2, 2, 6, 4. Okay, and we had how many decimal places? We had 2. So 1, 2. Okay, so this will come there, and this will come to the top. Okay, so let us rewrite this as theta equals 1332.64 divided by 4.2 squared, 17.64 multiplied by 22 over 7. Okay, we can multiply that by that. Okay, so 133. Okay, let's do it separately. 17.64 multiplied by 22. So 22, 2, that's 8. 2, that's 12, 2, that's 14, 15, 2, that's 2, 3, 0, and you're going to have 8, 2, 5, 3. We add them, we have 8, 0, 1, 7, 8, 8, 3. Okay, this is what we get. And we had how many decimal places? We had 2. So we're going to have that. And then we divide this by 7. Divide this by 7. Okay, we'll continue with the math till we get our final answer. Our final answer should be theta is equal to 60 degrees. 60 degrees. So if you continue with the math, you find that your angle is going to give you 60 degrees. And that is how you find the angle that we have in the middle there. So the thing is, it's all a bunch, or it's all a lot of math that you have to deal with, mental math. You have to do the calculations, you have to do the additions, the multiplications, and all that. So we can move on to question 13. Move on to question 13. Question 13 says, the mass of a block of wood, is 876.4 grams, correct to 1 decimal place. Complete the statement in the answer space below. So in the answer space, you've got M. This is M equals, you've got M, you've got less than, equal to, greater than, equal to. And we've got dashes this side. So the question is simply asking us to find what should be on either side of this statement. We've got M is greater than or equal to, less than or equal to. So how do we do this? So you know that if we have a decimal number, a number of decimal places, we can assume that that number has been rounded off to give us that number. And we know that if the number is, if we've got, let's assume we've got 0.00, let's say 0.0325. Let's assume we've got 0.0326. If I ask you to round this off to 3 decimal places, you'd say it's 0.033. If I ask you to round it off to 2 decimal places, you would say it's 0.03. Okay. So we find that if the number that is immediately being cut off is less than 5, then we can, the number that the last number that we're going to have will not be rounded off, it will not be increased or changed in any way. But if the number that is being cut off is greater than 5, then we would have to increase the last figure that we're going to have by a value of 1. So in the same vein, we've got 876.4. So you can assume this was 876.4, let's say 43. If we round it off, this will give us 44. 876.4. Or rather, if we had 876.4.39, if we round this number off, we're going to have 876.4. So this is what we're going to do. So we're going to find the lowest value that this number could have been. We're also going to find the highest value that this number could have been. So we're going to say this would have been 876.444. If we had 876.45, this would have been rounded off to 876.5. But if we have 876.44, it can be rounded off to 876.4. So this is the highest value that you could have had for this number M. So we can say this is 876.44. And then for the lowest, we can say we had 876.3.35. We can round this off to 876.3.4. So what if we had 876.34? It can be rounded off to 3, which is not much with what we have there. So meaning this is the lowest value that this number could have been, which is 876.35. And you're done with that question. Question 14, we are given, or rather it's on bearings, and we're given such a drawing. We've got 141 degrees, 225 and 35. We've got point A, point B, and point C. And we're told to find the bearing of A from B. So when they say A from B, means starting from the north of B, going all the way to where A is, meaning they are looking for all of this. The angle that is starting from that point, going all the way to that point. So how do we do that? How do we do that? So already we've been given part of that. We've got 225. All that we need to find is this angle in between there. How do you find that angle in between? So let's get this drawing and have it here. Let's just cut part of it. We're going to have this. Okay, this is our A and this is our B. This is our point A and this is our point B. Okay, and we have this to be 141 degrees. So if we extend this line and that line and that line and that line, would have something like this. Extended this one, extending this one. Okay, so these two lines are parallel to each other. This line and that line are parallel to each other. And if we say they are parallel, it means that this angle here is the same as the angle that we have. We take this to be a Z. So say this angle is the same as the angle that we have down here. So this angle is the same as the angle that we have down here. So it's also 141. And if this is 141, it means this one here on top is also 141. And this one at the bottom is also 141. And how do we find the angle that we have here? We know that this angle and this angle are exactly the same, and this all should be a revolution. And so what this plus, what we can simply say is this is a straight line. This is a straight line. So 180 straight line, 180 minus 141 give us the angle that is there, which is the same as the angle that is on top there. So we're going to say 180 minus 141. 7, 10, 9, 3. So we got 39. So 39 is there, 39 is there. So meaning this angle here is 39. So to find the bearing of B from A, we're going to say it's starting from there, going all the way to that point. And that is simply 225 plus 39. So 225 plus 39 will give us, 264. So the bearing of A from B is equal to 264 degrees. Okay, hope we're together. 264 degrees. We got the next question. This is the north at C. We're talking about the angle from here to point A there. So how do we find this angle that is here? So let's do what we did with the previous one. We take out part of our diagram there. We've got, this is our A, it comes down there. We've got that, this is our C, so this is our C, this is our A. We extend the line, you can extend this line, okay? You can extend this line, you can extend that line, okay? Okay, and we've got 141 there. And if this is 141, this is also 141. Sorry, 141 is it there? Sorry. Okay, this is what we have. This is what we have. This is what we have. Let's extend it to the other side as well. We've got point B somewhere there. And we're told to say this is 141 degrees. 141 degrees. So we can extend this to there. We can extend this to there. Okay, we can extend this to that side. And what else can we extend? Okay, that's it. So if this is 141, and we know that this is a straight line, to find the angle that is here, we can simply say 180 minus 141, which will give us 39. So we've got 39 degrees. We've got 39 degrees here. 39 degrees there. Okay. 39 degrees there. So what we're looking for is this angle that is here. So if we look at it from this perspective, we've got this, and we've got 35 degrees there, we've got 39 degrees there. So maybe we can find the angle that is there. This is a triangle, so we simply say 180 minus 35 plus 39. Okay, so 35 plus 39 will give us 39 will give us 9 plus 5 is 14, 4, 3, 3, 7, 74. So now to find the angle that is there, we simply say 180 minus 74, 7, 10, 6, 0, 106. So 106 is the angle that is there. How did you find the 106? This is a triangle. So this plus that should give us 180. And we work with that principle. So this is 106 and we have 39 there. So to find the rest of it, we simply say 106 minus 39 minus 10, 9, 16 minus 9 will give us 7, 9 minus 3 will give us 67. So we have 67 here, 67 there. And if we have 67 there, us having 67 here, and if we have 67 here, we say this and this are the same. So this 67 is the same as what we have there, which is 67 degrees. So now we're saying the bearing of A from C, so it's simply this angle that we're looking for. From C to A, which is 67. So the bearing of A from C, our final answer will be, so you need to remember that when you're dealing with bearings have to be given with 3 digits. So you say this is equal to 067 degrees, and that is the bearing of A from C. Okay, move on to question 15. Okay, and the first question is saying find F inverse of X. How do you find F inverse of X? The first thing that we do is replace the f of x with y. We've got y equals 2x plus 1. This is A. Y equals 2x plus 1. Then you make x the subject of formula. So this one goes to the other side. You have y plus 1 equals 2x. We divide both sides by 2 to get x equals y plus 1 over 2. And now we can replace the x with the f inverse of x. And the y with replace the y with the x. We're going to have f inverse of x equals to x plus 1 over 2. And we found f inverse of x. The next question is asking us to find fg of x. So we're dealing with composite functions. So it's simply telling you to say in f of x, where there is x, replace with g of x. So it's telling us to say in f of x, where there is x, replace it with g of x. So in f of x, we've got 2x plus 1. So wherever there is x, we're going to put 3x minus 5 over 2. So this is equal to 2. Where there is x, we replace with all of this. We're going to have 2, open brackets, 3x minus 5 over 2 plus 1. We simplify that, we get 6x minus 10 over 2 plus 1. Okay, so this is the same as 6x over 2 minus 10 over 2 plus 1. 2 into 6 is 3x minus 2 into 5, 2 into 10 is 5 plus 1. 1 minus 5 will give you 3x minus 4. And this is our fg of x. Fg of x. Okay, this is how we go about that one. The next question is asking us to find fg of 4. So wherever there is x in our fg of x, we replace it with a 4. So we're going to have 3, there's x there, so we put 4 minus 4. So 3 multiplied by 4 is 12, minus 4 will give us 8. So fg of 4 is equal to 8. And that is how we go about that question. On question number 16, we're asked to find, the first question is asking us to find A, D, E. A, D, E. The second one is asking us to find D, A, E. And the third one is asking us to find B, A, D. Okay, so how do we work on such a question? How do we tackle such a question? How do we go about it? So starting with ADE. So if this were paper 2, I would actually advise you to go through and find each and every angle that you've been asked to find. In fact, not even, you find every angle that you can find, even before you look at the question that you've been asked. But since this is paper 1, the questions are much easier for you to tackle, even without looking for the other angles. So we start with ADE. Where is ADE? ADE. So we've been given the angle here at the center, which is 80 degrees. And we are asked to find the angle there at the top. Okay, so now what you have to remember is that for triangles or for angles that are coming from the same chord, one angle is being made at the center, while the other angle is being made at the circumference of the circle. The angle at the center is twice the angle at the circumference. That is one principle that you should always remember. So if we've got 80 degrees here, meaning this one is simply half what we have there at the center. So meaning our angle ADE is half of 80. If we're given the angle at the top, we would say the angle at the bottom there is twice the angle at the top. But since we've been given the angle at the bottom, we would say the angle at the top is half the angle at the bottom. So we have ADE coming from the same chord, same points, point E and point A, as AOE. So this angle and that angle are both coming from the same point, which are A and E. Okay, so meaning the angle that we have there is simply half of 80, and that is 80 divided by 2 is equal to 40 degrees. So we've got 40 degrees as our angle ADE. So you can even write our 40 there, 40 degrees. The next one is DAE. 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 How do we find DAE? We've been taught to say this line and that line are equal. These two lines are equal. So meaning the base angles as well are equal. Angle DEA and angle DAE are both equal angles. They're the same angles. So if you find this one, it means we found that one. If you find this one, it means we found that one. And if you look at DAE, DA or DAE, we've got a triangle. We have a triangle. So to find the angles at the bottom, given the angle at the top there, and we're told to say both these angles are the same, we go by the principle of the angles, the sum of the angles in a triangle being equal to 180. So meaning 40 plus DEA plus DAE is equal to 180. But you know that this angle and that angle are the same. So meaning you can just say 2 times DAE. So you can say 40, I hope you can see, 40 plus 2 times DAE equals 180 degrees. So why have we said 2 times DAE? Because this angle and that angle are the same. So if we want, you can say 2x, we can say 2y, we can say 2 times DEA, 2 times DAE. It's all the same. So the 40 goes to the other side, we get 2 DAE equals 180 minus 40. And this gives us 2 DAE equals 140. Divided by 2 gives us DAE equals 70. So these are degrees, 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 angle, angle, angle. So angle DAE equals 70 degrees. So we have 70 degrees as our angle DAE, which is the whole of this 70 degrees. Okay, the next question is asking us to find BAD. So we've been given the 20 degrees, and this 20 degrees is coming from A and B, and we need to remember to say angles that are coming from 2 points, the same points, and touching the circumference of the circle. As long as they're coming from the same point and touching the circumference of the circle, those angles are the same. Those angles are the same. So we've got BCA, we've got, so angle C is coming from B and A. Is there any other angle that we have that is coming from B and A? Yes, we have angle BDA. We've got BCA, BDA. Both of them are coming from B and A. This one and that one. So meaning this is 20 degrees. This is 20 degrees, meaning the angle that we have at the top there, at the top at D there, is also 20 degrees. So we can write this to be 20 degrees. Good. When you look at this shape that we have a cyclic quadrilateral. We have a cyclic quadrilateral. Can you see it? I hope you can see it. Try to look closer. You'll see it. The cyclic quadrilateral that we have is A, B, D, E. Can you see it now? A, B, D, and E. Okay. So when we see a cyclic quadrilateral, the first principle that should come to mind is opposite angles should add up to 180 degrees. Opposite angles should add up to 180 degrees. So when we say opposite angles, this point is opposite to that point. This point is opposite to that point, meaning this plus that should give us 180. This plus that should give us 180. Okay, so we can use that principle. That principle is enough for us to find A. So there are actually two ways that you can do it. You can go with the triangle way, as I was saying, or you can just use the cyclic quadrilateral way, where you say this plus that should give us 180. And you already know to say, we said this angle and that angle are the same, so meaning this is also 70 degrees. This is also 70 degrees. Okay, so now if we add 40 plus 20, what does it give us? 40 plus 20 will give us 60. So we've got this whole angle here is 60 degrees. It's 60 degrees. So now let's assume this whole angle of the cyclic quadrilateral is x. So we're going to say 60, sorry, so we're going to say 60 plus this angle x equals 180 degrees. When the 60 goes to the other side, we're going to have x equals 180 minus 60. 180 minus 60 will give us 120. So x equals 120 degrees. Now this x is from this point to that point, but what we're looking for is simply the one that is there. So we can say x minus 70 will give us what's there. X minus 70 will give us what is remaining there. Cool. So let's get into that. So we're going to say x minus 70 gives us what we are looking for, which is angle BAD. So what is our x? 120. So 120 minus 70 equals to BAD. What is 120 minus 70? I can get you. 120 minus 70 will give us, I've forgotten, 50. To give us 50. So we've got 50 degrees here. So BAD is equal to 50 degrees. So BAD equals 50 degrees. Okay. So I was saying you can use, there are two methods that you can use to find BAD. You can go with what we've done, or you can say this plus that should give us 180. If this plus that should give us 180, it means that what we have here is simply 180 minus 70, which is 110. which is 110. Then this is a triangle, so we've got a triangle. So 110 plus 120 plus that angle should give us 180. 110 plus 20 will give us 130. 180 minus 130 will give you 50, which is still the same as the angle that we have found. So we can move on to the next question, which is question number 17. So when we talk of translations, we're simply talking of a figure moving, just moving the figure by some certain x coordinates or some certain x units and by some certain y units. So simply adding or subtracting, in fact, we're simply adding to the initial vector that we had. We add another vector and it will give us some movement in the x and some movement in the y. So to find the translation vector, we're going to say r plus a translation vector t gave us s, right? Cool. So to find t, we're going to say t equals s minus r. As simple as that. As simple as that. So we're going to say t equals, what is our s? 2, negative 1 minus our r, which is negative 3, 1. Okay. So 2 minus negative 3 will give us, this is simply 2 plus 3 will give us 5, negative 1 minus 1 will give us negative 2. Are you done? No. It tells you to express t as a column vector. This is coordinate vector. So to express t as a column vector, t is simply equal to 5 with the negative 2 at the bottom. And now you're done. As simple as that. We move on to question 17b. That's the question. And here is what we have on the answer space. We've got start, enter m equals output m and stop. And you're asked to find, to write what's supposed to be on the enter and what's supposed to be on the m equals. So how do you do it? Pseudocode is basically explaining what is happening. It's basically explaining what is happening. You might have a flowchart and you have to translate that into a pseudocode, or you have a pseudocode, you have to write that to translate that into a flowchart. So a pseudocode is something that you can understand by reading. A flowchart you can also understand, but it's got symbols and whatnot. So you're told to say this is a pseudocode for calculating the mean m of 10 numbers, and these numbers have a sum of s. So what are you going to put on your enter? So enter, you might put anything. You can put enter 10 numbers, or in some cases you might put anything to denote 10 numbers. You can say A, B, C, D up to the 10th letter, or but I prefer just writing enter 10 numbers. This will get you a mark. And for m equals, you've been told to the sum of the 10 numbers is s, so you say s, and you know that mean is calculated by the sum over the number, the number of figures or numbers that you are calculating the mean for. So you're going to say s over 10, since they're 10, and you're done. Simple as that. S over 10 numbers, and you're done with question number 17b. Okay, move on to question number 18. Okay, so let's go through question 18 together. And that y equals 10 when x equals 32 and z equals 4. Okay, so let's write that statement mathematically. So we're saying, given that y, so I advise you to do this even as you read questions on this topic. You translate each and every sentence into some mathematical language so that you can easily replace the values that the variables that you have with the coefficients or the numbers that you've been given as the values of those variables at that time. So we start y varies, so this is a symbol for varies, directly as x, so meaning x, and inversely over as a square of z. Square of z. So z squared. Okay. So this is what we have. And if we replace this with an equal sign, we say y is equal to kx. The k is introduced because we've put an equal there. Z squared. So k is a constant. So we need to find the constant given the values that we've been given that are full, given the y, the z, and the x that we've been given in the question. So we've been told to say, given that y equals 10, so as y we'll put 10 equals, and x equals to 32, so 32, but there's a k, so k over, and z equals 4. The first question is saying, find the value of k, the constant of the variation. So to find the value of k, so in cross multiply, we're going to have 40 equals 32k. Sorry. We've forgotten the squared. There's a squared there, so squared. Okay. Now what is 4 squared? 4 squared is 16. So this is the same as 16. So we've got 10, 32k over 16. 16 can go into 32 how many times? Twice. So 1, and there we've got 2. So 2k. So we've got 10 equals 2k. 10 divided by 2 will give us 5. So we're going to have 5 equals k. So therefore k, our constant of variation, is equal to 5. And you're done with question number 18a, 5. And you get how many marks? 1 mark for that. So the second question is saying, find y when x equals 20 and z equals 5. So we know that our equation is y is equal to xk over z squared, and we found k to be 5. So we got y equals x, or rather 5x over z squared. So I asked to find y given those two values. So we just replace them. In this variation equation that we have. So y is equal to 5. Where there's x, we'll put 20. Divided by z, we'll put 5 squared. 5 squared. So what is 5 squared? 5 squared is 25. So we've got y equals 5 multiplied by 20 is 100. 5 squared is 25. Y equals 25 into 100 is 4. So therefore y equals to 4. And that is our answer for question number 18b. You can move on to C. C is saying, find z when x equals 9 and y equals 5. Okay, so our variation is y equals xk over z squared. Yes. Okay, then we can replace with what we have. Y 5 equals variation constant is 5, x is 9, z is what we're looking for, so z squared. We can cross multiply, we'll have z squared equals 5, 9, 5. So notice that I haven't multiplied these two. Why? Because we don't even have to multiply. We can simplify even without multiplying. So we can simply cancel this 5 and that 5. We remain with 9. So z squared equals 9. We find the square root of both sides. We have z equals, square root of 9 is 3. This is our final answer. And we're done with question 18. We're done with question 18. We move on to question number 19. So we can look at the question and then let's tackle it together. So we've been told to say these are preference shares, PS, of 450. They are 450 at 10% of 50 kwacha each. Okay, then we've got ordinary shares, OS, which are 700, and they are 10 kwacha each, rather of 10 kwacha each. Then the company declared the dividend of 5,750. How much dividend will be paid to each ordinary share? So to find the amount of dividend that will be paid to the preference shares, we are going to multiply this by that, by that, this by that, by that. So we're going to say, this is for preference shares, we're going to say this is equal to 450, don't know I'm writing it on top, 450 multiplied by 10%, percent meaning over 100, multiplied by 50. Okay, so this and that can go, this and that can go. And we have 45 multiplied by 10 multiplied by 5. So we're going to have 450 multiplied by 5. Now what is 450 multiplied by 5? Simply 45 by 5, which is 25, 20, 22, 225. So we're going to have 2250. So this was paid to all the preference shareholders that we have in that company. And this is how much they had said they would pay to everyone. So we're going to say this minus that will give us how much the ordinary shareholders had to share amongst themselves. So we're going to say 5750 minus 2250. This is 0053. So we have 3,500. Now the question is not asking us to find how much all the shareholders received, but it's asking us to find how much each ordinary shareholder received. So we're going to divide this by 700. So divided by 700. Okay, so 7 into 35 is 5. So meaning they each received a 5 kwacha. That's how we go about it. Okay, move on to question. We are told that the ratio of the volumes of two similar solids is 64 to 27. The surface area of the smaller solid is 180 centimeters squared. What is the surface area of the bigger solid? So we've been told to say big over small. And then we've been told to say the ratio of the volumes is 64 to 27. Okay, so we've been given the ratio of the volumes. This is the volumes. And now we're asked to find the surface area of the smaller solid. How do we go about it? How do we go? The surface area of the bigger solid. So you know that volume is given by L cubic, right? Area is given by L squared, and the length is given by L. So we've been given the ratio of the volumes, which is L cubic of big, so we'll call it, I'll put a B there, to L cubic of small. Okay? So now, the volume of the bigger one is 64 to 27. So if we are to find the length of the smaller one, or the length of the bigger one, we'd have to find the third root of both these numbers. So what is the third root of 64? What is the third root of 64? Let's think. So what is the third root of 64 and the third root of 27? Third root of 64 and the third root of 27. So what is, start with 3. 3 multiplied by 3 multiplied by 3 will give us, yes, 27. So this is equal to 3 to the power 3. Then 4 multiplied by 4 multiplied by 4 will give us 64. So this is 4 to the power 3. So we have, so in short, rather, let me not write it like that. So in short, 64, this is 64 to 27. So this can be written as 4 to the power 3 to 3 to the power 3, which is that. So meaning the length of these two solids that we have is 4 and 3. And to find the area to find the area, would say, or rather, this is the ratio that we've used to find the volume, and it's also the ratio that you can use to find the area. So we can say we've been given the area of the smaller one to be 180. So we can say area of small AS is equal to 180. So we can say the small one is this one, so 3 to 180. Then 4 to x. So 3 times x is 3x. Then we've got equal to 4 multiplied by 180. We divide both sides by 3. By 3, we get x equals 3 there, 1, 3 there, 6, 0. 4 multiplied by 6 is 24. So we're going to have x equals to 240 centimeters squared. So let's run through this again. So we're given the ratio of the volumes. If we're given the ratio of the volumes, you can find the initial ratio of the lengths, which we did here. We know that volume is L cubic, so to find the length, we would simply say the square root or the cube root of the volumes that we've been given, and that will give us the ratio of the lengths. Given the ratio of the lengths, we can find the ratio of the area, which we did there. So that is how you go about this question. We can move on to the next question. So this is question number 28, and it's asking you to say the diagram below shows triangle KLM. KL is 16 centimeters, KLM is 150 degrees, and the area of the triangle is 32 centimeters squared. 32 centimeters squared is equal to the area of this figure. And you're asked to say, find the length LM. Calculate LM. This is what we're looking for. How do you find LM? How do you find LM? Okay, firstly, how do you find the area? How did they find this area? So we know that area of a triangle is given by half BH, which is half the base times the height. But in this case, we do not have a perpendicular height. No, we don't. So the other formula that we use to find the area is area of a triangle is equal to, trying to think of letters to use, let's say BC sine A. The area of the triangle is given by, as I was saying, the area is given by BC sine A, and this is all divided by 2. Okay, so area is given by BC sine A divided by 2. Or some will write it as half BC sine A. So now I do want to use the A because it's conflicting with that. So let's say BC sine D. Okay. So meaning you'd use, in this case, you'd use two angles and two lengths, and the angle that is sandwiched by the two lengths that you have to find the area. That is when you do not have a perpendicular distance. So two lengths and the area, the angle in between the two lengths that you've used. So in this case, our area is equal to, so this is M, this is K, this is L. So we're going to say MK sine L over 2. Or we can write it the other way as half MK sine L. Okay, so now what is our M, what is our L, what is our K, and what is our sine 150? So now the challenge that you might face, I believe everything else is simple, but the challenge that you might face is finding sine 150. What is sine 150? How do you know what sine 150 is? So we need to remember to say, when we think of quadrants, when you think of quadrants, all angles in the first quadrant are positive. In the second quadrant, only sine is positive. The third quadrant, tan is positive. And in the fourth quadrant, only cos is positive. Okay, so 150 lies in the second quadrant where sine is positive. And the sine of 150 is the same as the sine of an angle in the first quadrant. The sine of an angle in the second quadrant of sine, the sine of an angle in the second quadrant is the same as the sine of a corresponding angle in the first quadrant. So how do you find the corresponding angle in the first quadrant? We're simply going to say 180 minus 150 will give us the angle in the first quadrant, which will give us 30. So sine 30 is the same as sine 150. And you know what sine 150 is from that. But now what if you don't know what sine 30 is as well? How do you know what sine 30 is? This is how we know what sine 30 gives us. So sine 150 is the same as sine 30. And what is sine 30? We come to this funny triangle, basic triangle, with 60 degrees. Let me do a bigger one. We've got this triangle. We've got let's give it as 1 centimeter, 1 unit, 1 unit. And you've got 60 degrees there, meaning this one is also 60, and this one also is 60, such that the angles will give you 180. So if we were to cut this angle in half, it means that we no longer have 60 there, but we have 30 there, and we have 30 there. Okay, we have 30, 30. And this is 1, this is 1, this is 1. So let's give them values of 2. So this is 2, this is 2, this is 2. Meaning we've got 1 here and we've got 1 down there. Okay. So now how do you find sine of 30? Sine 30 is simply equal to sine theta equals opposite over hypotenuse. Opposite over hypotenuse. And this is a right angle triangle. These are right angle triangles that we have at the bottom there. So sine 30 is equal to the opposite divided by the hypotenuse, which is that. So sine 30 equals, what is the opposite? 1 over our hypotenuse, which is 2. So sine 30 is equal to half. Therefore, sine 150 is also equal to, yes, half. Okay. So we come back to that formula that we had, that equation. We said the area is equal to half MK sine L. We can replace, well, we've got area, we'll put 32 equals half, where there's M, which one is M? 16. Where there's K, we'll leave it as K, that's what we're looking for. Or actually, let's leave it as LM, because that's what the question is asking us to find, LM. And sine L is sine 150. Sine 150 is the same as sine 30, which is the same as half. Okay. So what is half of 16? Half of 16 is 8. So we've got 32 equals 8 multiplied by half LM. What is half of 8? Is 4. So 32 equals to 4 LM. What is LM? LM is simply 32 divided by 4. What is 32 divided by 4? We've got 8, 16, 24, 32. So it's 8. So LM is therefore equal to 8 centimeters. And you are done with question number 20A. You get the full 2 marks for just doing that. Okay, move on to question number 20B. Question number 20B is saying the equation, it is saying the equation of line A is, equation of line A is 3x plus 2y equals 10. Line B is parallel and passes through four, 6. Find line B. Okay, so given the equation of line A, we're given that line B is parallel to line A and it passes through those points. We're asked to find line B. So why are we given line A? Line A is given to us so that it can help us find the gradient of line A, which is the same as the gradient of line B, as they are parallel. Parallel lines have the same gradient. So how do we find the gradient? You know that the equation of a line is given by y equals mx plus c. So we just need to isolate the y and push everything to the other side, and we find the coefficient of x, and that is our gradient. So in this case, we've got 3x plus 2y equals 10. So 2y equals 10 minus 3x. Y equals 10 over 2 minus 3x over 2. So y, now write it in that order. We have minus 3 over 2x, right? Plus 10 divided by 2 is 5. So therefore, the gradient is 3 over 2. Okay, we've got 3 over 2 as our gradient, and that is what we're going to use to find the equation of line B. So since they are parallel, same gradient, just plug it into the equation, find the constant, and you're done. So we know again y equals mx plus c. Gradient is that one. Y, this is x comma y. So what we're doing now is basically just finding the value of the constant c. So we place x and y and the gradient. So while there's y, we'll put 6 equals, while there's the gradient, we'll put 3 over 2. While there's x, we'll put 4 plus c. This one, this 2. 6 equals 6 plus c. 6 goes to the other side, we get 6 minus 6, which is 0. So c equals 0. So the equation of line B is y is equal to 3 over 2x plus 0. But this is useless, so we can just do that. And this is our line B. This is our line B. And we are done with question 20B. We go on to question number 21A. This is what we have for question number 21. This is what we have for question number 21, and it is asking you to find the inequalities that define the unshaded region R. So we've got 1, 2, 3, and 4 inequalities, and we're asked to find all 4 of them. So let's get into it. So the easiest ones to start with are these horizontal and vertical ones. So we've got one horizontal and one vertical one. So for the horizontal one, it's passing through 6. I hope you can see the 6. There's a 6 there. So I hope you can see the 6. So it's passing through point y, 6. So this inequality can be written as y. So this is how I do it. You write your coordinate there, y, and 6, the value 6. So now we look at the wanted and unwanted region. Which region do we want? Are we interested in? Is it the one below the y equals to 6, or is it the one above the y equals to 6? So we're interested in the one down there. So we're going to say what we really want is y is less than or equal to 6. Y is less than or equal to 6. That is what we're interested in. This is our first one. Our second one, we've got, let's look at the vertical one. It's passing through 2. Hope you can say 2. So we write x. This is in the x, and we write 2. Are we interested in the less than or the greater than? We're interested in the less than. So sorry, I didn't see this. Y is less than or equal to 6. So we're interested in the less than, so we're going to say x is less than or equal to 2. Now we come to the tricky ones. So the other one that is very easy to look at is the one that's passing through 0. So if you were to look at it, if you were to look at the question from the paper itself, you find that this one is passing through the points 1, 1, 2, 2, 3, 3, and so on. Just wouldn't do that. But once you find a line that is passing through such points, you should know that line is y equals x. So if it is slanting like that, it means it's y equals negative x. Am I right? Yes, y equals negative x. Okay, and if it is going like that, it is y equals positive x. Okay, so we can say our third one is y, and we put negative x at that point. Y and negative x. So now what are we interested in? Which part is greater than the other? Is it this part or that part? How do you know? Okay, so let's pick this point. Let's say we pick 4,4, which is, I believe 4,4 is on the wanted region. So in the wanted region we pick 4,4. So if we say 4, so we've got y and negative x. So if we say 4 and 4, negative 4 is negative. 4, negative 4. Which one is greater? The one that is greater is this one. So we put the same symbol there, and we're done with this inequality. We come to this other one. So for the fourth one, we'll have to find the gradient. We'll have to find the equation of that line. So how do we find the equation of this straight line? So to find the gradient, we'll pick any 2 points. Let's pick these 2 points. So we've got, this is negative 2, 0. And then this one is 0, negative 0,4. So to find the gradient, we'll say y minus y over x minus x. This is equal to, which ones are y? 0 minus 4. Which ones are our x? Negative 2 minus 0. Mind the way I've written. Take note of how I've written it. 0 minus 4. That's 0 minus 4, negative 2 minus 0. These are y's, these are y's, these are x's. So if you're starting with down to top, if it's top to down, you know what I meant. So 0 minus 4 is neg 4, neg 2 minus 0 is neg 2. 1, 2. So our gradient is 2. So our gradient is 2. And you know that, so gradient of this line is 2. M equals 2. We're finding the equation of that line. So to find the equation of the line, we say y equals mx plus c. So we pick, let's say we pick this point as the one to help us find our c. So this is negative 2, 0. So it's negative 2, 0. So this is x, this is y. So while there is y, we put 0 equals, while there is x, we put negative 2 multiplied by 2. Okay, and what else? Okay, so you got negative 2, 0. Okay, yeah. So this is plus c. Negative 2 multiplied by 2 will give us 0 equals neg 4 plus c. C is therefore equal to 4. So our equation will be, so c equals 4. Our equation of the line will be y equals to mx plus c. Okay, y equals to mx plus c. Then upon doing that, we replace with what we have. So y equals, what is our m? 2x plus 4. But this is not an equality. We have to remove this, and we try to pick any points and replace them in there to see which how our inequality will look like. So let's say we pick 0, 0. 0, 0 is in our wanted region. So I always advise to pick points in your wanted region. So 0, 0 is in our wanted region. So we're going to say, what is why we put 0? We'll put 0, which will give us 0. 2 multiplied by 0 is 0. We'll have 4. So now, which sign do we put there? Put this sign, because the 4 is greater than the 0. So our fourth inequality is y is less than or equal to 2x plus 4. And you are done. So if you do not understand, then rewind the video and go through question number 21. Move on to the last question. So integrating, this is calculus, and integrating is where you have an expression for the gradient and you're asked to take it back to the initial expression that you had. So this is how we go about it when you've got a x to the power n. To integrate this, let's say y equals that. To integrate this, we get a x to the power n. We add 1 to the power of x, and we divide everything by n, which is the power of x plus 1. That is what we're going to do for each and every term that we have. So for the first one, we're going to say this is 3x to the power 3 is 3x to the power 3 over 2. So to integrate this term, what we're going to get is 3x to the power 3 plus 1, right, over 3 plus 1 multiplied by what we also have at the denominator there, which is 2. So we're going to have 3x to the power 4 over 4 multiplied by 2 give us 8. And you're done with this term. So for this term, we've got, I'll write it on top. We've got 3x to the power 4 over 8, right? So we do the same for the second term. We're going to say 5x, right? So we increase the power of x by 1. We have 5x to the power 1 plus 1 over 1 plus 1, which is 5x to the power 2 over 2. We can't divide that, so we just leave it as it is. So this becomes 5x to the power 2 over 2. Okay, we're moving step by step. We come to the last one. So you've got 1 over x squared. This is the same as x to the power negative 2. Remember that. Always remember that we've got 1 over x to the power something. We can put that x on top and it will have a negative power. So we've got this. Maybe let me write it. So this would become x to the power negative 2 plus 1 over negative 2 plus 1, right? So what is negative 2 plus 1? It's simply negative 1. So we've got x to the power negative 1 over negative 2 plus 1 is also simply negative 1, right? So this can be written as negative 1 over x. Do you agree? Yes. Why? Because this negative can be, this is showing that this whole thing is a negative. Negative 1, the power negative 1 can be put down, the x can be put as a denominator, having a positive power, which is positive 1, which is that. So you can write this as 1 over x. And now to write our final answer as a whole, we're going to have 3x to the power 4 divided by 8 plus, sorry, there was a minus here, so minus 5x to the power 2 over 2 plus 1 over x. And you are done with that question. Okay, move on to number 22, to question number 22b. Question number 22b is saying find, oh no, sorry. So we're done with A. Now B is saying, given the function y equals 1 plus x brackets multiplied by x minus 2 brackets. Question A, or rather B1 is saying sketch the graph, sketch. So if we're asked to sketch, this equation that we have, to sketch this function that we have, this is how we go about it. So we're just sketching, or not plotting it as it should be, but it will have a general shape that the shape of the original plot should have. So just sketching. So this is how it's going to look. Okay. So when you're asked to sketch, you have the best thing, the only thing that you can do is look for the zeros. What do you mean by zeros? Point where x is equal to 0, point where y is equal to 0, and we look for the general shape that the graph is going to have. So let's start with finding the zeros of x. So the zeros of x means that where y is equal to 0. So if y is equal to 0, we've got 0 equals 1 plus x multiplied by x minus 2. So for us to get 0 in y, it means that either this or that is 0. Because for you to get a 0 upon multiplication, it means that one of the terms that you're multiplying is 0. So either this or that is 0. So we've got 1 plus x equals 0, which is x equals to negative 1. And we've got x minus 2 equals 0, which is x equals 2. So we've got those 2 points, negative 1 is here, and we've got 2, our 2 is here. So the graph should pass through those 2 points. We've gotten that. Okay? Then the next thing that we should do is look for the x0 point. So to find the x0 point, we're going to put 0 where there is x. So we're going to say y equals 1 plus 0 multiplied by 0 minus 2. So this is y equals 1 multiplied by 0 minus 2 is negative 2. So y equals negative 2. So we've got y equals negative 2 here. So our negative 2 in the y is here. So graph should pass there as well. Then you need to get a general shape of the graph. So what is the highest power of x? The highest power of x is x squared, because x multiplied by x will give us x squared. You can't have x to the power 3 because we only have 2 x's and both of them at the power 1. So x multiplied by x will give us 2, or x multiplied by 2 will give us x multiplied by x will give us x squared. So it only has one turning point, either one minimum or one maximum. And is it facing upwards or is it facing downwards? Does it have a minimum or does it have a maximum? We look at the first thing that we're going to have. If we say x squared, x multiplied by x will give us x squared. Is that positive or negative? Is it negative x squared or positive x squared? It is positive x squared. If it is positive, it means it has a minimum. So meaning our graph should come in that way, and looking at what we have, meaning it should come and pass through this point. We're just sketching, so it should be something like this, something of that nature. Something of that nature. So if you sketch this on your answer sheet, you get full marks on that particular question. You get the full marks on that particular question. Okay, move on. Yes. So this was question 22A. Question 22B. Question 22B is saying find the minimum of value y. Find the minimum value of y. Find the minimum value of y. How do you find the minimum value? So minimum value, it simply means the point at which the gradient is 0. So the best way we can do this is by expanding this. So we've got y equals 1 multiplied by x is x, 1 multiplied by negative 2 is negative 2, x multiplied by x is x squared, x multiplied by negative 2 give us negative 2x. So you can group the like terms. We've got, let's start with x squared minus 2x plus x minus 2. This is x. So x squared minus 2x, okay, this and that will give us x minus 2. 1 minus 2 will give us negative x minus 2. So now to find the gradient, find the expression for the gradient, we differentiate. Calculus, bring in calculus, we differentiate this. And since it's a minimum, it means the gradient is 0. So when we differentiate it, the expression that we're going to get, we equate it to 0. So we differentiate this, so to find dy over dx, this is equal to, so to differentiate, when you've got a x to the power n, to differentiate we simply say, this n comes down, we're going to have n multiplied by a, x, then n minus 1, and you're done. So in short, we're going to say this 2 comes down, we're going to have 2x, then the 2 minus 1. Differentiate this one as well, minus, so the power 1 comes down, 1x, 1 minus 1. Now when you get a constant doesn't have x, so we leave it, we forget about it, we erase it. It's not considered in differentiating. Yeah. So we can simplify this further, and we've been told to say it's a minimum, so the gradient is equal to 0. So dy over dx equals to 0. So you can replace this with 0. 0 equals 2x, 2 minus 1 is 1, 1 minus 1, x minus 1 minus 1 is 0, so x to the power 0 is 1, so you have 2x minus 1. So this 1 can come to the other side, you get 2x equals to 1. X equals to 1 over 2. So you found the value of x, and now we can find the value of y by replacing it in, let's replace it in this equation. This is the same as that, we just expanded. So y equals, where there's x, we put 1 over 2, 1 over 2 squared, sorry, y is equal to 1 over 2 squared minus 1 over 2 minus 2. Okay. Half squared will give us 1 over 4 minus half minus 2. Okay, that is where we are. And quarter minus half will give us 1 over 4 minus 1 over 2. This is 4. 1 minus 2, which will give us where are we? Quarter minus, oh yeah, 4. 1 minus 2 will give us negative 1 over 4. So that is what we are getting. Have we done something wrong? Quarter minus half will give us, okay, yeah, so that is what we will get. So this will give us negative, hope you can still see, negative 1 over 4 minus 2. Negative 1 over 4 minus 2. We can erase this. Negative 1 over 4 minus 2 over 1. Our lowest common denominator is 4. Negative 1. 1, 4, 2, 8 minus 8. We'll get negative 9 over 4. So this is the value of our y. So y is equal to that. So now the minimum point will be negative 1 over 2, comma, negative 9 over 4. 9 over 4. And now 9 over 4 is simply 2, 1 over 4, 2 and a quarter. 2 and a quarter. So let me just write the answer here so that you can see it. So minimum is negative 1 over 2, comma, negative 1 over 2, comma, negative 9 over 4. Negative 9 over 4 is simply the same as -2 1/4. And if you can go back to the sketch that we had made and try and prove, you find that it actually does make sense to have -2 1/4 as our minimum in the y, because the lowest point was -2 according to our sketch, so meaning it was just lower, the turning point was just somewhere down there. And that is how we do tackle question number 22b. Now we can move on to the last question. Okay, so we're finally doing the last question. This is question number 23. Question number 23. And A is saying, find the acceleration in the first 2 seconds. Acceleration in 2 seconds. In 2 seconds. So where is our first 2 seconds? Our first 2 seconds are there. Okay, so how do you find acceleration? Acceleration is equal to v minus u over time. What is our final velocity? Our final velocity is 10. Our initial velocity is 0. So we have 10 minus 0 over the time taken, which is 2 seconds. And this gives us 5 meters per second squared. And we're done with A. We're done with A. So this is a velocity time graph. You have the speed, you have the time, you have a weird shape, and you're asked to say acceleration in the first 2 seconds. First 2 seconds is there. So we know this is the speed, is the time, and to find acceleration, say the final velocity at the end point, which is the final velocity at the 2 minus the initial velocity at 0. So you say 10 minus 0 divided by the total time taken, which is 2 seconds. And that is how we find the 5 meters per second squared. Move on to B. We move on to B. Now B is saying find the value of V. Find V given retardation, which is retard in 8 seconds. In 8 seconds, last 8 seconds is 3 meters per second squared. So if asked to find the retardation, given that we asked to find the value of V, given that the retardation in the last 8 seconds are these 8 seconds, is 3 meters per second squared. So we still apply the same formula that we use for acceleration, and that is acceleration. In this case, let's say retardation is equal to V. So in this case, we're going to say U minus maybe V minus U over T. Okay, V minus U over T. So you can say negative V minus, this is retardation, it's negative. So we say negative V minus U over T. So we're given the retardation to be 3, put 3 there. What is our final velocity? Our final velocity is 0. So negative 0 minus, our initial velocity is V minus V over, how many seconds did it take? Last 8 seconds, so 8. So you cross multiply, 8 by 3 is 8 by 3, 24. So we've got 24 equals 0 minus V is negative V multiplied by negative is V. So V equals to 24. So therefore our velocity is equal to 24 meters per second. And we're done with B. We're done with B. We go on to the last question, which is question 23C, which is asking for the average speed of the whole journey. Average speed of the whole journey. So given the final velocity, the final speed, and the initial speed, which is 0. So it was in between V and 0. So we found our V to be 24 and our initial to be 0. So to find the average speed, we simply say 24 plus, maybe let's say, we can say V plus U over 2 to find the average. So the final, or maybe the highest velocity minus the lowest over 0. So we're going to say 24 plus 0 over 2. So 24 plus 0 is 24. 24 over 2 will give us 12. So therefore the average speed is 12 meters per second. And we are done with this paper. Thank you very much for watching, and I hope you've gotten something. Hope to see you soon. Or hope you see me soon. Thank you very much.